Hello everyone, welcome to 10-Minute Physiology. In today's video, we're going to be talking about projectile motion problems and how to approach them. So with that, let's give it a go. So I'd like to begin by first describing to you what projectile motion is. So let's just say we have a cannon, and this cannon is in an open field that is flat. And let's just say that when we fire this cannon, a baseball shoots out and ends up a certain distance away from the cannon. Now, if we were to trace the ball's movement, what we would see is something like this, a parabola. And if we were to look at the ball at a certain period of time, we could examine different velocities that are acting upon it. So let's take a look. So let's take a look at right when the ball leaves the cannon. So right when the ball leaves a cannon, it has a specific velocity or initial velocity. So this black arrow here shows the initial velocity of the ball, or the velocity that the ball has right when it leaves the cannon. And what we can see with this initial velocity vector is that it has both an x component and a y component. So we can break up this particular vector into its x and y components. So the initial velocity in the x direction looks something like this, and then the initial velocity in the y direction looks something like this. So what we see here is that the initial velocity in the x direction is pointing towards the right, and the initial velocity in the y direction is pointing upward. So when we blow up this figure, we can see that we have a few things here. So the first thing is that in order to calculate the initial velocity in the x direction and the initial velocity in the y direction, we need to know what theta is, or the launch angle. And we also need to know what the initial velocity is. And by using simple trigonometry, we can come up with two equations that help us to calculate what these two components are. So the initial velocity in the y direction can be calculated by this equation, where the initial velocity in the y direction is equal to the initial velocity times sine theta. And the initial velocity in the x direction is given by this equation, where the initial velocity in the x direction is equal to the initial velocity times cosine theta. So these are the two equations that you need to know from this. So now that we know how to calculate these two components, how do the velocities in the x and y direction change over the course of the flight? So let's see how the initial velocity in the y direction changes as the ball moves through the parabola. So during the course of the flight, the ball is experiencing an acceleration in the y direction. And this acceleration is going to be the acceleration due to gravity. And what we see from this diagram here is that the initial velocity in the y direction and the acceleration due to gravity are pointing in opposite directions. The acceleration due to gravity is pointing towards the ground, and the initial velocity in the y direction is pointing upward. Therefore, the acceleration due to gravity is actually causing the velocity in the y direction to decrease as the ball approaches the top of the parabola. So as the ball goes up to the very top of the parabola, the velocity in the y direction is decreasing. And in fact, when the ball is at the very top of the parabola, the ball is going to have a velocity in the y direction being equal to 0 meters per second. And the ball isn't going to speed up again until it starts coming back down to the ground. So it will go from 0 meters per second to a greater speed. So now that we know how the velocity in the y direction is going to change throughout the course of the flight, let's talk about how the velocity in the x direction will change during the flight. So the velocity in the x direction is actually very interesting, because if we assume that air resistance is negligible, or that drag is negligible, the velocity in the x direction at the very top of the parabola is going to be equal to the initial velocity in the x direction that we had when the ball was just shut out. So assuming that there's no air resistance or that there's negligible drag, the velocity in the x direction will remain constant throughout the entire object's flight. So now that we have the basics of projectile motion down, let's start using these concepts in order to do some practice problems. So let's start off with this problem. An object is shot out of a cannon at an initial velocity of 5 meters per second. The object is shot out 30 degrees relative to the ground. What is the total flight time? Assume that g is equal to 10 meters per second squared. So this is the magnitude of g. That sine of 30 is equal to 0.5, and the cosine of 30 is approximately equal to 0.87. So take a moment, pause the video, and try to figure out what the answer is for yourself. So hopefully you took some time to attempt this problem. So the correct answer to this problem is going to be choice A, 0.5 seconds. So let's see why. So I like to start off with these types of problems by drawing a diagram. So let's start off by drawing our ground And let's draw our initial velocity vector. And the initial velocity vector is equal to 5 meters per second. And we also know that the launch angle is equal to 30 degrees. And we know that this is a projectile motion problem, so let's draw our parabola, where our parabola extends all the way from the launch point to an unknown distance away. So how do we go about solving this problem? Well, in order to find out what the total flight time of the object is, we need to first figure out what the initial velocity was in the y direction. So the initial velocity in the y direction is given by this equation, where the initial velocity in the y direction is equal to the initial velocity times sine of the launch angle. And when you start plugging in those values, what you get is an initial velocity in the y direction being equal to 2.5 meters per second. So now that we have this initial velocity in the y direction, we can now figure out what the total flight time is. And in order to do that, we need to know our kinematic equations of uniformly accelerated motion. And the three big ones are these three. And the one that I'm going to use is going to be the first one. Vf equals Vi plus At, where Vf is the final velocity, Vi is the initial velocity, A is the acceleration, and T is the time. So what I'm going to do is I'm going to modify this equation to find the velocity in the y direction. And when I do that, I get this equation, where the final velocity in the y direction is equal to the initial velocity in the y direction plus the acceleration due to gravity times the time. So this equation is going to be used to solve for something very important. This equation I'm going to use to solve for how long it will take the object to get from the launch point to the highest point in the parabola. And the reason why I'm doing this is because if I find the time that it takes to get to the highest point, I know that it will take the object double that time in order to get all the way to the end. So in other words, by finding out how much time it takes to get to the top, we just multiply that value times 2 in order to get the total flight time. So in order to calculate how much time it gets to the top, let's first solve for time. And when we do that, we get this equation. And now what we can do is start plugging in the values. So the final velocity in the y direction in this particular case is going to be 0 meters per second. And the reason why it's 0 meters per second is because remember, at the very top of the parabola, at the highest point, the velocity in the y direction is going to be equal to 0 meters per second. We know that the initial velocity in the y direction is 2.5 meters per second, and we know that the g is equal to 10 meters per second squared. So when we do the math, what we get is a time being equal to 0.25 seconds. So this shows us how much time it takes to get to the top of the parabola. Therefore, in order to get the total flight time, we just need to multiply this value by 2. And when we do that, we get a total flight time being equal to 0.5 seconds. So it took the object 0.5 seconds to get from the launch point all the way to this point right here. So now let's do our second question. So the second question is using the same scenario, but we're asking something different. So an object is shot out of a cannon at an initial velocity of 5 meters per second. The launch angle is 30 degrees. What is the highest point that the object will reach? Assume the object is shot from ground level and assume that g is equal to 10 meters per second squared, that sine of 30 is equal to 0.5, and that cosine of 30 is equal to 0.87. So take a moment, pause the video, and try to find out what the answer is for yourself. So hopefully you took some time. The correct answer for this question is choice B. Let's see why. So once again, let's draw our little diagram. And what we're solving for this time is we're trying to solve the highest point that the object will reach. And we know from our little diagram here that the highest point is going to be at the very top of the parabola. And if we know that, it actually makes this question quite easy to solve because we already solved for a lot of the information that we needed. So the first component that we need is we need to know the velocity in the y direction. And the initial velocity in the y direction was 2.5 meters per second. We also need to know the time that it took in order for the object to get from the launch point to the very top of the parabola. And the time it took was around 0.25 seconds. So in order to solve for the highest point, we're going to use this kinematic equation, where the final position in the y direction is equal to the initial position in the y direction, plus the initial velocity in the y direction times the time, plus the acceleration due to gravity times time squared over 2. Now, what we're going to do is we're going to start canceling out some variables because we can. So since the object is starting off at ground level, we can say that the initial position in the y direction is equal to 0. So we can cancel out that term. Now what we can start doing is plugging in our values. We know that the initial velocity in the y direction is 2.5 meters per second. We know the time that it takes to get to the very top of the parabola is 0.25 seconds. And when we do that, we get a final position being equal to 0.31 meters. So that's why this is the answer. So once again, an object is shot out of a cannon at an initial velocity of 5 meters per second. The object is shot out at a 30-degree launch angle. How far away will the object land? Assume that the object is shot from ground level, that g is equal to 10 meters per second squared, sine 30 is equal to 0.5, and cosine 30 is approximately equal to 0.87. So take a moment, pause the video, and try to find out what the answer is for yourself. So hopefully you took some time. The correct answer to this question is going to be choice B, 2.18 meters. So let's see why. So once again, let's start off by drawing our diagram. It's the same diagram that we've been using for this whole time. The first thing that we need to know is the initial velocity in the x direction. And to find the initial velocity in the x direction, we use this equation, where the initial velocity in the x direction is equal to the initial velocity times the cosine of the launch angle. And when we start plugging in those values, we get an initial velocity in the x direction being equal to 4.35 meters per second. So the next thing that we need to know is the time that it took to get from the launch point to the unknown distance. And we know that the total flight time was equal to 0.5 seconds because we calculated that earlier. So now that we know these two things, we can easily calculate how far away the object landed. Now, since the air resistance is negligible, we know that over the course of the object's flight, that the velocity in the x direction remained constant. Therefore, we can use this equation in order to find the displacement, where the initial velocity in the x direction is equal to the displacement over time. And when we solve for the displacement and plug in our values, we get a displacement being equal to 2.18 meters. So that's it for this video. I hope this video helped you get a better understanding of projectile motion problems, and I hope to see you in the next video. Thank you for watching, and I hope to see you next time.